We made our AP Chemistry final in Minecraft. We represented the connections between concepts using floating islands. The big island acts as a center point for all 9 islands floating around it. Each of these themed islands are connected to the center island through bridges. The surrounding islands each represent a unit of a class and are labeled 1 through 9. Directly related islands are connected through short bridges which are colored blue. There are 2 main highway bridges that connect opposite sides together and create a web of bridges. Additionally, there are 3 extra short bridges to attach the rest of the islands to the main system. All concepts are in one way or another connected, and the island and bridge system that we constructed helps to portray that idea.
Indeed, here we have unit conversion, otherwise known as dimensional analysis, represented by a stonecutter. Here we have sig figs with operations dealing with positive and negatives, of course, as 0 and 1 are significant figures.
A mole is a unit of measurement and is equivalent to approximately 6.02 times 10 to the 23rd. Atomic mass is the mass of an atom measured in AMU. Molar mass is mass over number of moles. This is a mass spectrum showing the abundance of ions. Mass percent equals mass over total mass times 100%. The Aufbau principle helps to count electrons in their electron levels. Hund's rule shows what shells electrons are in. This is a Bohr model that shows the nucleus and 2 electrons in the first electron shell. Here are 3 different types of bonds: ionic bonds with ions, covalent bonds with shared electrons, and polar covalent bonds with unequal sharing of electrons. Coulomb's law is F equals K times Q1 Q2 over R squared. This is the Lewis structure for H2O. These are 5 VSEPR models. These are the S, Px, Py, and Pz orbitals. The 3 main intermolecular forces are London dispersion, dipole-dipole, and hydrogen bonds. The 4 types of solids are ionic, metallic, molecular, and covalent network. The 3 states of matter are solid, liquid, gas. The ideal gas law is PV equals nRT, and the combined gas law is P1V1 over T1 equals P2V2 over T2. Molarity is M equals moles per liter. This is a mixture that was separated using chromatography. This is the electromagnetic spectrum, including radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Photon energy is calculated using E equals HF, and C equals lambda V can be used to calculate wavelength or frequency. Emission spectrums are used to find the frequencies of electromagnetic radiation.
We have, of course, the physical reaction represented by a transition from ice to water. On the other side, we have a chemical reaction with the combustion of fire. Introducing stoichiometry, which is changing products and reactants, and dimensional analysis, which is represented by the, of course, stonecutter. And here we have a transition between mass, moles, and moles again for B. And then here we have a limiting reactant, of course, limiting the amount of reactants you have, and that changes what the product can be. And lastly, we have percent yield, which is a formula of 100 times actual yield over theoretical yield. Here we have the different types of ionic equations. The first one is the molecular equation. Second one is a complete ionic equation, and the last one is net ionic equation. Here we have oxidation reduction reactions, which use assigned oxidation numbers, and oil rig is a good way to remember this, using oxidation is losing and reduction is gaining, of course. Rate laws, which are represented by the equation R equals K, concentration of A, concentration of B. And we have a table of all the rate orders, differential rate laws, interintegrated rate laws, and characteristic kinetic law. Over here we have the course of the reaction mechanism, comprised of elementary steps, including catalysts and intermediates. And of course, over here we have collision theory, which is based on 3 characteristics of frequency, energy, and orientation. Over here, we're describing catalysis, which is speeding up the reaction, reducing activation energy, and of course they are also present in reaction mechanisms. Here we have a system with a catalyst and see how fast it grows throughout the reaction.
First, you can see the calorimeter. So calorimeter is a way of like measuring the heat change. It melts the water, and you can collect the water, and it just shows you how the water, the temperature changes. So we have delta H. Delta H is positive when it's endothermic, and delta H is negative when it's exothermic. And we have Hess's law. Hess's law is a way of measuring like delta H with multiple reactions, just a way of adding them and just like so you can find out delta H. Moving on, we have the eternal flame, which represents the first law of thermodynamics. So thermodynamics says that energy is not created or destroyed, conservation of energy. So we have heat of vaporization, heat of fusion. We have the graph. This just shows how substances change from solids to liquids to gases.
Here we have our first learning outcome, covering of course the equilibrium constant K with the appropriate equations, and of course Q, which always wants to be the king of the scenario. Here's KSP, which is the solubility equilibria, has common ion effects, and these are calculating pH and solubility. And here we enter the Rice table cave. Of course, there's initial change in equilibrium and the appropriate concentrations. And as we turn around the bend, of course, here's a description of Le Chatelier's principle, represented by a seesaw in Minecraft.
The lava represents the acid, and the water represents the base, and the cobblestone represents salt. So acid-base reaction. And if we head into the shack, we have 3 definitions of acid: Ross and Lowry, Arrhenius, and Lewis. And then we have PaOH and pH and what they are. All right. Moving on, we can go to the titration, and we have the 3 titrations: strong acid, weak base, weak acid, strong base, and strong acid, strong base. And we have a titration curve, and how it looks like. You can see the entire shape of it and how it just spikes up at the equivalence point. So we have the table, which shows what pKa is and what is Ka and what is Kb. Henderson-Hasselbalch equation, which is just pKa plus log of base over acid. We have the shrine of the buffer. This buffer just shows us how the blue and red, which is the acid and base, are balanced. Alright, we here have a galvanic cells and a few equations representing it. So the E naught by the E naught equation, and the delta G is equal to NF minus NF E. And so if we go up here, we get the water of delta G. If you go up it, it's not spontaneous. If you go down it, it's spontaneous. So we have a few more equations of delta G relating it to delta H and delta T and delta S, and we have it relating it to K. So let me make more equations. And then we head over this way. And we head over to the second law. What is second law of thermodynamics? It states that universe always goes to increased state of entropy. And what is delta S? It's a change of entropy in a system.